All right, so let's do the best we can with what we have. I have a backup sound system here. All right, so we are in the right place, we're in the right class, and this is the textbook that I base most of the slides, but this is not the only textbook that I use. I use several resources. Okay, I have some other books that I like, some topics I like more in some other books, and also some other sites like Osmosis or Lectorial. But whatever you need, I'm going to give it to you. All right, don't go out like signing up for these extra sites because they tend to be kind of expensive. Okay? So that is the Cubby textbook, and it's actually quite easy to find this edition in PDF forms. So, actually, last immunology class, somebody found it for free. So, I'm all for saving money if it is possible, right? So, if you can get it for free, like, why not, right? All right, so here, just to make sure that we know what we're doing with the grades, right? So we do have grades from 4 exams. Technology is really driving me crazy today. Here, all right. So grades from 4 exams, and then you have your quizzes, and then you have your extra credit. I will not fight with it. So that was the link for the iClicker, right? So just in case you have your phone and you want to connect with the class iClicker, or if you want to just put the code and you have the remote, right? You should be able to hop in there, right? Everybody got that? Okay. Okay, so here is a view of the modules in your Canvas, right? So you do have this introduction to basic concepts is just an outline of what is going to be said in the class, but it's actually just redundant because I always put the objectives in the first slide for each lecture. So this is just a bit redundant.
Excuse me 1 second.
Yeah.
So to get the laptop connection working, I'd had to do a lot of troubleshooting, like going back and forth, which would interrupt the class. What I can do is in between classes, I can come back, make sure the laptop connection's working.
Okay.
And it'll be okay for your next class.
Yeah, if you can just make sure that it's going to work for Thursday, I'm happy.
Yeah, absolutely.
Okay,
Yeah.
in the meantime, we go for, prehistoric
Right, I just don't want to
setting.
interrupt. I don't want to waste more of your time.
Okay, thanks.
Yeah.
Thanks, I appreciate that. And I have no idea why my pen is not working. It was working yesterday. Maybe it's a position of it. Anyway, I'll go with the finger. Okay, so here we go for the PowerPoints. You will see that the PowerPoints that I have in the module, they're from the last time that I taught the class, so the last term, right? I usually update the PowerPoints before the class, right? So when you are studying, it's the same information, but just before we come to class, I always put in some more relevant or information or some recent research, or sometimes I look at the slides and I say, what was I thinking? And some things that made sense when I prepared the slide, it didn't make sense after I looked at it again. Okay, so I'm thinking this is confusing. I don't know what I'm talking about. And if I don't know what I'm talking about, I cannot expect you to know what I'm talking about. So I do go over the slides and improve as we go along. Okay, so you're going to find always a PowerPoint here just before the class. And when you have your quiz, the quiz is going to show up like right at the end of the module for the week. Okay. Now you notice here that I have 2 unpublished links that are for the videos, right? And the reason is because I don't have the videos yet. I'm only going to have the videos after the class. So as soon as we're done with the class, I upload the video and that link is going to be open. Okay. And why am I saying that? I mean, you look at the module and you're going to say, well, it's obvious. I would think so too. And then what happened? Last term, 2 weeks before the end of the term, there was a girl that came to my office and she said, Dr. Waziri, I missed 3 classes, and how can I go over the material? I said, why don't you watch the video? She goes, what video? I said, okay, maybe I didn't emphasize it enough in the class, right? So there is a video for every class. All right. Oh, and this is a cool stuff here. If you like to play video games, right? Although this video game is not as updated as I would like for it to be, but this is a fun thing to do. Like you go to this ImmuneQuest site, and the code for the class is right there. Okay, so you can register yourself and start playing the free version of the ImmuneQuest game. I know they have another paid version, but I just like to save money whenever possible. Right? So do the free version, cover the innate immune system, and we're happy. All right? Is it a must? Do you have to do this? No, this is for fun. When do you do this? Well, when you are tired of studying from the book, right? And when you start reading and words are not connecting, they are not making sense, that's the time you go play video game. All right? Everybody cool with that? All right. Okay, so here we're finally starting with the overview of the immune system. Yay. Okay. So these are the learning objectives. And yes, I know it's a lot of learning objectives here, but we're going to go over each one of those. And again, keep in mind, this is just a broad view of all the things that are happening in the immune system, right? So I do not expect you to become an expert right on the first day of class. It's going to take a little time, a little getting used to, and it's going to take, you do have this learning curve of getting used to different parts and different cells and different functions, but we're going to get there. Okay. Okay. So here is the first suggested video that you can just click the link and have this nice overview of the immune system. So this is part of the Osmosis platform. Okay. All right, so here is your optional activity on ImmuneQuest. And this is what I like about it, because at first, when they started developing this video game, they really emphasized on innate immunity. So this is the type of immunity that you are born with, and you have cells that are ready to work as soon as you encounter some pathogen. Okay. So, they do have some nice concepts that are explaining the work of macrophages. Those are the big eaters, so the cells that eat a lot. Those are the macrophages. And then you have here the process of phagocytosis. That's the process of eating stuff. It could be microorganisms, or it could be cellular debris. So phagocytosis is when the cell takes up stuff. Okay. And you also have recognition of microbes, and not only microbes, but you can also have recognition of damaged cells. So in this case here, they're talking about microbes. So when a cell goes to recognize microbes and is a cell of the innate immune system, then the cell recognizes these patterns, okay? So they have molecular patterns on the surface of microbes. And then you're thinking, well, it's on the surface of microbes, and what is the proper name of calling these patterns? Well, you say it's pathogen-associated molecular patterns. Okay, so those are really on the surface of microbes that have to be recognized, and we're going to talk a lot more about these patterns. Okay. Now, you only have a certain number of receptors that can recognize those patterns. Okay. So those receptors, we are going to call them pattern recognition receptor, right? Because that's the job of those receptors, to recognize patterns. So when you see something that says pattern recognition receptor, you know you're talking about a receptor that is present in innate immune cells. Okay? Innate immune cells. This is working. This is nice. Okay. So you have a certain number of these patterns, and you can imagine what are these receptors. These receptors are made up of proteins. Okay, and how do you get proteins? Everybody took cell bio? transcription and translation. So in order to get transcription and translation, you have to have the genes encoded in the DNA, right? So here you're going to have DNA, you're going to have transcription, you're going to have translation, you're going to end up with a protein that is going to go to the surface of your cell. This is a cell. And this protein on the surface of the cell is going to be your pattern recognition receptor. Now you can imagine there are only so many genes that you can have for those patterns. So there are not a lot of receptors available out there for these innate immune cells. Okay? There are a few hundreds of them, and that's it. So when you talk about the immune system, of course, you have to talk about the presence of microorganisms. And a lot of times we start thinking about bad bugs, right? So you think about microorganisms, you think bacteria, viruses, diseases, and that kind of thing, right? But it's not really the case all the time, 100%. I mean, we have a few bad bugs, but most of the microorganisms are actually good bugs, right? Have you heard of the microbiome? Yeah. Who has heard of the microbiome? Okay, I want to see your hands. Like, if you're going to go for it, I mean, this is a yes or no question here. Okay, who has never heard of the microbiome? Okay, one person. And who didn't answer? Are you awake? Yes? Yes, awake or no? Oh, good. All right, so what is the microbiome? These are all the microorganisms that live with you. Okay, so you have bacteria all over your skin. You have bacteria in your gut, and you have it in your mucosal tissue, you have it in your hair, in your fingers, in your eyes. You have bacteria everywhere. Some bacteria even live in your bloodstream, and we never even bother to detect them. Some microorganisms, I mean, check this out, live in your brain. Scary stuff. Have you heard of this book that is called I Contain Multitudes? Check that one out. I'm going to put a link for it, or at least a link for one of these guys' talks on a TED Talk or something. So the name of the author is Ed Young, and he's a great author and very entertaining, and he was really focusing on microorganisms that have a very strange way of infecting the host and modulating what happens to the host, and a lot of times taking over the host's behavior. That is it's something really that we really wouldn't think about it until recently, right? So a very classic example of it is the parasite Toxoplasma gondii. Have you heard of that guy? Anybody took micro? Yeah, Toxoplasma causes toxoplasmosis. No? It's a type of disease that is quite dangerous if you're pregnant in the first trimester, right? And usually your obstetrician is going to tell you, well, if you have a cat, make sure that you don't change the cat litter, right? Anybody heard of that? No, yeah, toxoplasmosis. Oh, why? Okay, so check this out. The cat is the target of this microorganism, right? So the toxoplasma has to get into the intestines of the cat for it to grow, to reproduce, okay? Now, how is it going to get there? Well, what happens is that toxoplasma can hop on different species and then be carried to the cat. What am I talking about? Well, what is it the cats like to go after? Mice, right? Anybody watch Tom and Jerry? You know, it's ancient history, right? All right, so cats go after mice. And if you have a cat at home that lives indoors and outdoors, most likely you got some nice presents of live mice, sometimes rats, sometimes iguanas. Believe me, I do have a cat. So what happens? So toxoplasma can infect a mouse, but it's not going to be pathogenic to the mouse. Okay? So mouse gets infected, and something happens to the mouse. Guess what happens? Changes the way it behaves. Okay, if you are a smart mouse, and you know a cat is around, what is it you're going to do? You're going to run away, right? You want to keep your life, right? Now, if you're a mouse infected with toxoplasma, and you smell cat urine, that mouse is like, I love that smell. I'm in love with the cat. Where is that kitty? Okay, that's the mouse. Not very common behavior, okay? So the mouse starts to search for the cat and offers itself as lunch. It will die happy, okay? So the mouse falls in love with the cat. Okay, not normal. And then what happens? Toxoplasma somehow is going to get in the gut of the cat, right? Because the cat is going to eat the mouse. All right, so that's the mouse is the mode of transportation for that cat. Now that type of communication between a microorganism and the central nervous system of this temporary host, that is fascinating. What are the connections that this toxoplasma had to manipulate in the brain of this mammal, of this rodent, right? In order to make it change its behavior, in order to make it really fall in love with somebody that's not supposed to, right? Scary behavior. All right. Now, you should be asking yourself, right? Can we be infected by toxoplasma? Yes, we can be infected. Most of the time is in a temporary infection. Your immune system is going to take care of it, and no lasting symptoms, no sequela as far as we know, right? But we don't know much, because there was a study done, I believe it was in 2017 or so, but even it was in the Netherlands. So there was a study done examining post-mortem brains of car accident victims. Okay? Not only that, but car accidents that were correlated with risky behavior while driving. Okay, so if you ever drive on 95, you know what I'm talking about, right? You're minding your own business, you're doing everything right, and then all of a sudden you get this crazy creature of creation, read my mind what I want to call them, right? That just cuts in front of you, of course, without the signal. I mean, it's a sin to use a turn signal on I-95 in Florida. I mean, you put the turn signal, what's the first thing anybody else is going to do? Let me speed up and not let you go. And sometimes they look at you like, I passed you. And you go like, God bless you. Right. So risky behavior. So the scientists looking at the brains post-mortem after death of these people that engaged in risky behavior. You want to guess what was the result, what they found? 70% of those accidented people were infected with toxoplasma in their brain. Toxoplasma was happily living in their brains. That is scary. I don't know what is the percentage of the population that is actually infected by toxoplasma. I don't think there is a test for it. I didn't actually look for it. Maybe there is. Okay? Now, when you start thinking about tendencies of risky behavior and what could be in your brain, you should start thinking, maybe that's not all me deciding on how to behave. Maybe there are microorganisms that are telling you or giving you little hints on how to behave, right? Anybody likes roller coasters? Risky behavior, skydiving? hiking, I know Alps and mountains with bikes, and then like biking like 80 kilometers an hour or something like that downhill. Yeah, so I like that. Yeah. I like roller coasters, and there are some people that are like, oh no, that's too risky. Risky? I mean, roller coaster risky? It's a lot riskier to go driving. But it's okay. Some people just can't take it. Yeah. Now, if you have certain tendencies for this type of excitement, right? Maybe there is something in your brain that is telling you that that kind of stuff is exciting, instead of telling you that kind of stuff is dangerous. Stay away from it. Okay? And this is when we get to this part of the microbiome. So there are very good bugs that are always with you. Okay? So those are your commensals. It means they started with you and they will be with you for all of your life, as long as you treat them well. Okay, so commensals are good for you. And we know a lot nowadays about the commensals that are in your intestines, so the intestinal microbiome. And we know that the commensals are very important for training your immune system. Okay? So the proper development of your immune system is going to depend on the presence of those microorganisms. So a lot of them, the highest percentage of them are bacteria, right? But you also have viruses, you have fungi, so you have other things that are present in there, and they are shaping the behavior of your immune system. Okay? And nowadays we know even more about it, that you have a certain level of communication between those microorganisms and your central nervous system. Okay? When you look at the intestines, you'll see that the intestines have a lot of neurons, and they basically have their own neurological system in there. So we do say that the intestines are really like your second brain. Okay? Now, because the presence of those commensals in your gut, okay, and because of the presence of this communication highway, we know that the commensals will send messages from your gut to your brain. Okay, and that happens every day, all the time. And interestingly, it also follows a circadian rhythm. Okay? So during the day, you have certain bacteria that are more active. When the sun goes down, you have other bacteria that becomes active, that they become active. Okay? And the behavior of the bacteria, it's fascinating, because the good bacteria, they are going to thrive if you feed it well. You feed them what they like to eat. So to keep a good immune system and good bacteria and great health and great brain health, you need to eat well. That means what? Vegetables, fruits and vegetables, preferentially without pesticides, or at least some organic pesticides that are not as harmful as some other ones out there, right? Fruits and vegetables, fibrous, natural fiber. Broccoli. Oh, bacteria love broccoli. The good bacteria love broccoli. Now, you have bad bacteria there too. Okay, we're gonna get to that. Now, let me go from here. All right, I'm like diverging. I start talking too much. All right, so let me follow us in the PowerPoint here. So what is going to influence the microorganisms that are everywhere? And by the way, they are everywhere. Even a few weeks ago, some scientists discovered a microbiome inside the microwave. Talk about nuked bacteria. I mean, they will survive microwaving. Okay? Imagine if you have a dirty microwave. What's brewing in there, right? They have bacteria in hot thermal vents, and everywhere you can think of, there is bacteria for that. Okay? So let's say that you live in a dorm with a roommate, right? So the microbiome that is in you is going to be closely related to the microbiome of this roommate. Or let's say you have a partner, or you're married, or. So if people are living together, you're going to share a lot of the microbiome, okay? If you live with your family, people in the same family, in the same household, share the microbiome, okay? Why? Well, mainly because the diet is similar. You might be eating things that are prepared for everybody at once, right? And then you're going to see here that, okay, let me see here. Okay, so diet and the environment. Okay, this is very, very important to select what kind of microbiome is going to be on you and in you. Okay, so now let's say, for example, that if you leave home and you decide to just, come to a dorm because it's more convenient, you can just go to class and go to sleep, right? So then your microbiome is going to change. It's not going to be very similar to your family's microbiome. It's going to get to be more similar to whoever you live with in a dorm. Okay. Now let's say if you have a pet, so the microbiome of your pet is also going to help your immune system to develop, right? And people who have pets usually have better immune systems than people who don't have pets. That's why I have, cats and dogs, and I mean, I just love them. All right, so what is influencing your microbiome? Now, the age of the person also influences the microbiome. So we know that in order for the microbiome to be established, that's going to take place during early infancy. So until about 3 years old or so, from birth to about 3 years old, that's the time when you get your commensals to get into the intestines and all this microbiome business to get established. Okay? But as you get older, the microbiome changes. Okay, and a person who is really old has, of course, different microbiome than a young person. Okay, so it changes with the age. Now, presence of antibiotics, that's a big one, because most of antibacterial antibiotics are not very specific. They just kill a bunch of bacteria that have certain characteristics. Okay. So when you take antibiotics, you might be killing the bad bacteria that is causing a disease, but you might also be killing a lot of the good bacteria that are keeping you healthy. Okay, so taking antibiotics can be also a big factor on your overall microbiome health. Okay. Okay, so let me see here. Okay, so microorganisms are everywhere. Okay, so let me see here. So here, the role and proposed purpose of these microorganisms, right? So if everything is working just fine, so we say that we are in this symbiotic process. Everybody's happy living together, right? Symbiosis. So what does that mean? That means that when you look at your intestines, you're going to see that the microbes that are in there, they are only in there. Okay, so you have a very good gut barrier. So the mucosa is healthy and thick, and the microbes that are in there, they are not thinking about going through your intestinal wall and getting into your system or into the blood. Okay, they're happy in there. This is the idea of good fence makes good neighbors, right? We're in this symbiosis. I like my microbiome, my bugs like me, and we all happy, everybody's good. All right, symbiosis. Okay. So with that, you're going to have a very good interaction between your gut and your brain. So we call that the gut-brain axis. Right? So everything is happy, symbiosis, everybody's feeling good. Okay? Now, the guts, the microbes in your guts, they are not going to shape your immune system and your brain function, but they are also going to shape your metabolism. Everybody knows what is metabolism? Yeah, anabolic, catabolic, what you eat is what you burn and things like that, right? Well, now we know that everyone has a very unique type of metabolism, And that is dictated by the gut microbiome, what bugs you have in your intestines. Okay? And I'll give you an example here that is a classical example. So there was this woman that acquired antibiotic resistant type of bacterial infection. That was C. difficile infection, right, which you have also next slides. So this woman, she couldn't get rid of that infection. And, you know, she could die, and she was very sick for quite some time, until a doctor suggested that she should try a fecal matter transplant. You know what that means? Yeah, exactly what it sounds. You get poop from somebody and you stick it in your intestines. Yeah, very not a very good image in your head right now. Okay, now, there's a fecal matter transplant. And she is so disgusted by it that she said the only person that she would accept such a thing would be from her daughter. Fine. So the daughter donated the matter, fecal matter, right? Open a jar, okay. So took to the lab, you know, made a solution out of it, meaning they put in a blender with saline solution, right? Yeah, interesting. And then they put in an enema and up it goes, right? And the mom got the fecal matter transplant and it cured the C. difficile infection. So bacteria was gone, right? We're going to get into more details on mechanism of how that works. Right? Main idea, bacteria was gone. She was cured, right? Fecal matter transplant is over 90% effective in getting rid of antibiotic resistant C. difficile infection. Okay? So that became a mainstream type of therapeutics for this type of problem. Okay? But then what happens? This woman started to gain weight. She was never fat in her life. Never. She was always normal weight. But her daughter was always overweight. And now this woman started to become overweight, and there was nothing that she would be doing that could help her to lose the weight. And when they figure out what's going on with the microbiome, it happens that her daughter had certain bacteria that were interfering with the metabolism and made her gain weight. So yeah, if you're overweight, you can blame your microbiome for it. Right. You can change your microbiome too, to get rid of those bugs, hopefully, right? That would be a great idea to get into the pharmaceutical industry. You're gonna make a lot of money, right? I mean, after the GLP-1 agonist, everybody's on some kind of Ozempic or Wegovy or something like that nowadays. Also interferes in microbiome function. They get you good microbiome. You gotta look at the mechanism of how that's happening, right? Okay, so we're looking here at what happens when everything goes well, right? You have a balanced immune system function, you have a great metabolism, and your brain is working well, everybody's happy. Now let's say something goes wrong with your intestinal bugs or some bug in your system, right? Some of your microbiome. Now that's what you call dysbiosis, okay? So this is some homeostatic imbalance. Something went wrong. That's disease. First thing that's going to happen is that your gut barrier, meaning the mucus in your gut, that's going to start fading. You're going to start having like holes that are not going to be protective. So you're going to have some penetrance or some type of invasion of this bacteria that can get into your system. Okay, so this is permeability change. Okay, now you're going to have gut-brain axis that is not very well regulated. So it's going to interfere with your brain function. You're going to start having, foggy type of thoughts, or you're going to start feeling sad or tired. You want to isolate yourself. You know how you feel when you're sick, right? You're kind of like, you don't want to be interacting with anybody, just like, leave me alone, that kind of thing. That has to do a lot of the guts, right? All right. And your metabolism here is going to be disrupted. You are going to have some type of inflammation. Am I blowing the time? No, we're going to 4:50, right? Okay, just check. Just let me know because I usually just talk forever. All right, so here you can have some type of inflammation. Or inflammation is good if it is acute inflammation. Okay, temporary, only to kill the bug type of inflammation. If you have constant inflammation, that is a problem. That becomes chronic inflammation. That's a big problem because chronic inflammation never goes away. Once you develop chronic inflammation, that's it. There's no way to go backwards. Okay, it only gets worse. You can manage it not to get worse very quickly, but once you have some chronic inflammation, it's a downhill type of thing. Okay, so chronic inflammation can happen with dysbiosis, and of course you can have neurological impacts of all this dysbiosis. And we know, based on recent studies, that certain neurodegenerative diseases like Alzheimer's and Parkinson's are very much related to certain types of bacteria in the gut. Okay? So when you look at this big picture and you say, I better eat healthy, right? There are good reasons for that, right? Okay. So here, this is an example of what happens when you have to take some type of antibiotic, right? And what happens to the bacteria, in this case, in your gut. So let's say here, if you only have good bacteria, so you have here your commensals and you look at the number of bacteria, so they're all happy and they're dividing and they're doing good things and keeping you healthy. So everybody's happy. Now, let's say that you had some type of infection and the doctor prescribed some oral antibiotics, right? And usually when you take oral antibiotics, you have to take those for a certain period of time, like a week or 10 days, right? Because you have to kill enough of a certain bacterial type enough in order to get them in low numbers so then your immune system can take care of the rest, right? So you have to take the whole course of antibiotics, right? Now, the problem is that the antibiotics are not going to only kill the bad bugs. They're going to kill all the bugs that have the pathway for that certain antibiotic. Okay? And the worst type of antibiotic, the type of antibiotics that will kill more bacteria are like the broad spectrum antibiotics. Okay? Those are going to kill whatever bacteria you can encounter, most of them, unless the bacteria is resistant, right? So let's see what happens here. If you took antibiotics, you kill some bad bugs, but you kill a lot of your good bugs as well. Now let's say that on top of all, you had some pathogenic bacteria, those are the red guys here. You had some pathogenic bacteria that were present like from the beginning, although they're not shown here. So let's put one little bacterium right there. So this is your one pathogenic bacteria that was there in the middle of all these good commensals, right? Now, when this bacterium was there all by itself in the middle of all these good guys, well, this guy here didn't really have a lot of chance to do harm because it was being checked by the good guys. Okay? Well, how? Well, as you can imagine, in order for bacteria to survive, what do you think they need? It's just a simple question. What do you need to survive? Friends, you need food, right? So when the food gets here, you have a lot of these guys in big numbers. They're gobbling down the food, gobbling up the food. They're eating it all up, right? So this guy over here doesn't really have a lot of chance to eat a feast out of that food that got into the intestine, right? So he can't really be growing a lot because all these other guys are eating everything, right? So this bad guy is quiet. Now, when you kill most of the good guys, your bad guys that are resistant to the antibiotic, they are going to start to multiply. They are going to start to proliferate because they have more food and they have an opportunity to proliferate, okay? And you're going to say, well, isn't the good guy also going to my tongue is twisted. Okay. And they also going to grow in numbers? But, yes, but remember, the good guys were not resistant to the antibiotic, so they are kind of quiet right now. They stay in this quiescent phase that they don't want to be dividing very quickly. But the bad guys, oh, those divide very fast. If they're resistant, they're going to divide very, very fast. And then what's going to happen? First thing that you have to keep in mind here is that it's not that your intestine was free of bad guys. It's just that those bad guys are opportunistic. If they have a right opportunity, they will take over. Okay? They don't have a right opportunity if your gut is intact, if you don't take antibiotics. But as soon as you do, these guys are going to start multiplying quickly, and they will take over. Okay? So this is a type of opportunistic infection that was brought because of the presence of these antibiotics. And now these bad guys can do a lot of damage. Okay? They can start eating the mucosal part of the mucosa, the mucus, right? They can start eating the mucus. They can infect the cells of the intestines. They can loosen up the junctions between the cells, right? The tight junctions. They can penetrate and go into your bloodstream. So they can really make you sick. And worst of all, those guys are resistant to antibiotics, so no matter what you take, it's not going to kill them. Okay? Now, there are some ways, some new therapies of taking care of resistant, or call them pan-resistant microorganisms. But those are not, very much explored nowadays because reality is that pharmaceutical companies do not have a profit with those kinds of drugs. Sad reality. We'll talk more about that later. Okay. So the idea, what is happening here? You have opportunistic pathogens. They can flourish in case they have a chance to do so. Okay? And the classic example here is antibiotic-resistant C. difficile type of infection. So everybody cool with that? Concept is easy? Yeah. Am I going to ask you about it? Yes. All right. It always makes good test questions. Okay, so here, the big picture is important to understand what's going on with the big picture and how those cells are working together in order to protect you from those opportunistic pathogens. Right. Now, those cells of both innate and adaptive immune system, not only they have to work together, they also have to be very cautious with their actions, because if they become overactive, they can cause disease. Okay, so you have certain diseases that are called autoimmune diseases, and those are like rheumatoid arthritis, multiple sclerosis, lupus, and even diabetes. Okay, so diabetes is autoimmune disease. And you can bet there is a bug for that. There is a bacterium, there's a type of bacterium that if you have it and you're eating the wrong foods, that bacterium can cause type 2 diabetes. Very scary. Okay, let me ask you, what is it that this type of bacteria like to eat? Those are not the good bugs, those are the bad bugs. Take a guess. Sugar, processed foods, white flour, all this stuff that you think about eating when you are studying late at night, that's the stuff that these guys like. Okay, the bad bugs like, okay? Yes, I know it's not fair when you look at your nice microbiome and your commensals and you're thinking, well, they like the fibrous foods, they like the veggies, they like the broccoli. Why am I not craving broccoli in the middle of the night? What comes to my mind? Chocolate chip cookies. Chocolate. Cakes, pastry, bread. Yeah, okay. that's not the good food, right? I mean, it's going to feed your bad bacteria. Okay? So keep that in mind when you're studying. It's going to study for immunology. What is your preferred snack in the middle of the night? Broccoli. Carrots, right? Carrots and broccoli and lettuce. Put some olive oil, a little salt. Yeah, and then you tell yourself, this is so yummy. Mind over matter. Don't bring cookies into the house, because if they are in the house and you have to choose between broccoli and cookie, guess who's going to win? The cookie. Oh, by the way, I always bring chocolate to the class, and that's for participation. I really remember to bring some of it. If you took classes with me before, you know that I like, student participation and questions and things, and then you ask a good question. You ask a question at all, and you give any sign of life, I usually throw a chocolate. This class is small enough that I don't need to go for long projectile motions. My big auditorium classes, I sometimes take this slingshot. I'm getting better at it, especially with those chocolates. Good projectile motion. All right, so yeah, stay away from processed foods, except if it is classroom chocolate. A little bit of chocolate is okay. Too much of it is not okay. Right? All right. We get more into this kind of stuff later. Right. So here, let me just keep track. Okay, so I will take five more minutes here. All right. So this is from the osmosis video, right? And it starts to talk about what composes the immune system. So you have several things that are very important for this whole system to work. Okay. So you have three main things here. You have organs of the immune system. That includes primary organs and secondary organs. Okay. You also have tissues, and you have the cells, and you have free-floating molecules. Those are proteins in the blood and in the lymph. Okay, blood and lymph. So you have all these players that come together to keep you healthy. Now, what is the job that they have to do? First of all, they have to know what is a threat. They have to identify when something is bad. But as importantly, they need to identify what is good. Okay? Because imagine if you just think now, about the microbiome and all these bacteria in your gut that are good for you. If your immune system mounts up an attack on the good bacteria, then you're doomed, right? I mean, you're going to get sick. Okay? So immune system has to distinguish not only self from non-self. Actually, we are classifying microbiome as self lately, so yeah, that's good. Okay. But it has to also identify what is good microorganism and what is bad microorganism. So this immune system has to be very smart about this. It has to identify good viruses and bad viruses. Yeah, there are such things as good viruses. And we don't even talk about them because, just the good guys. It doesn't make the frontline news, right? I mean, you hear anything good in the news? Usually not, right? If you have something good in the news, nobody ever remember it next day, right? So the good guys, the good viruses, good bacteria, who's thinking about them, right? The immune system has to think about them. They have to distinguish what is good and what is bad. They also have to distinguish, of course, what is self, right? Because you don't want your immune system attacking your own cells. That's bad, okay? So that can kill you, right? Those are autoimmune diseases, okay? All right. Now, after you mount an attack, you have to get rid of that pathogen, right? And then you have to remember who you killed, okay? So there are several lines of defense that the immune system is going to use in order to get rid of pathogens and make sure they don't come back. Okay, as we're going to go through all these different levels of attack until we get to the memory and quick activation of the immune system. All right, so here are some cute bugs that can infect you and make you sick. Okay, so the bad guys here. Okay, of course, here you have HIV virus. You have here a picture of influenza virus, right? Staph bacteria, so that can give you staph infection, right? And you look at these guys here, oh, listeria, oh, that bug. And you have fungi that can cause a lot of trouble too. Okay, it's kind of difficult to kill a fungi, right? Unicellular. Then you look here, you have strep bacteria. So those are like little chains of little coccus, right? So strep can give you like strep throat, right? Strep bacteria. You have this guy here that swims around. That's your salmonella. Do you know how you get salmonella? Raw chicken is also, or uncooked eggs, or if you have pet turtles or reptiles, they can give you salmonella, right? And this is why when you go to a pet shop, I'm not sure if they have those silver dollar little turtles, the cute little ones. No, they say it's not appropriate if you have small children in the house. Why? No, kids put everything in their mouths, not only their hands, right? Oh, little turtle, looks like a little pancake, huh? Believe me, the kids do strange things. You can imagine what they put in their mouths, right? Yeah, so salmonella, they can get salmonella. Depending on the strain of salmonella, it can kill them, okay? E. coli can kill them too, by the way. Depends on the strain of the E. coli. E. coli is a very common bacteria present in your gut. If it is just commensal, that's okay. If it is not the commensal type, then you're in trouble, right? Okay, so you have another type of internal bacteria. Those are the tiny ones, like tuberculosis type of bacteria, right? Candida fungus. Oh, Candida albicans. What that causes? Yeast infections. Not fun. Is Candida present on you? Yes, all the time, most of the time. It's part of microbiome, as long as they do not grow out of proportion. If they do, that's a problem. Guess what makes Candida grow? Sugar. Anything that's going bad, and I ask you, you can bet sugar. All right? Candida loves sugar. Okay. Oh, this guy here, trypanosoma. Oh, that's a parasite. You know what that causes? Sleeping sickness. Not very common in this country, right? And this other guy, oh, helminth worm, intestinal worms. There are specialized cells to deal with those guys too, right? All right, different types of organisms that can cause disease, right? So basically, you are possibly under attack all the time, right? So you're surrounded by these things that can get you infected all the time. There is no such thing as a very clean environment that you're not going to have these things around, okay? And this is an interesting thing because if your immune system is doing its job, you're going to be healthy. Now, two people put in the same room, if one has a weak immune system and the other one doesn't have a weak immune system, that person can get sick and the other person is not going to get sick. You expose different people to the same viruses, some people will get sick and other people will not, okay? Depending on how well your immune system functions. And this is really, really interesting, especially when you're in a setting like this, a college classroom setting. Maybe you notice that just before some exams, a lot of people get sick. And it's not their imagination. It's because of the immune system. And I'm going to show you one of the mechanisms of how that works. Okay? So yeah, I understand, if somebody gets sick, and you're like, oh, I'm coughing, I'm dying, I can't take the exam. Well, let me know if you're sick and you cannot take the exam. I don't expect 50% of the class to be sick, not take the exam. Okay? But I'm saying, based on how we know how the immune system works, that kind of stuff can happen. Okay? We'll go into more details later. Are there strategies that you can use in order for that kind of stuff not to happen? Oh yeah, if I ask the question, most likely the answer is yes. Right? So first thing is good food, good habits, good sleep patterns. Make sure you have good sleep hygiene. Okay? Make sure you get your beauty sleep. Ideally 8 hours a night. Yeah, I know, doesn't happen. I know. Guilty, yeah. But you try to have a good night's sleep. We try to have a productive night of sleep. Like when you dream a lot and you wake up fresh, even if you didn't sleep a lot, but the quality was good. Right? So there are some strategies and there are some things that you can eat or teas that you can drink to help your body to relax and use your sleep time more productively. I'll be giving you these clues here and there, okay, because it's very relevant to this class. Okay? Well, I'm going to stop here. So if you have questions or comments, or if you're going to say anything. Huh? Yes.
So it's biotics.
Oh, okay, that's a good question. If somebody is taking antibiotics, right, and the doctor say, well, take probiotics, usually yogurt, right? It's a good idea because the yogurt has a good bacteria to repopulate your commensals. So they are dying, but you're going to be replenishing your gut with good bacteria. So you're going to keep the bad ones down.